Hello everyone, this is Chris Beekler with Alta Labs. Today I'm going to show you how firewall groups work on Route 10 and why they're one of the easiest ways to make your firewall, NAT, and policy routing configuration cleaner and easier to maintain. At a high level, firewall groups let you define reusable collections of ports or network destinations and then reference those groups anywhere you need them. So instead of typing the same ports, subnets, or host names into multiple rules, you create the group once and reuse it throughout the system. On Route 10, firewall groups can be used in firewall rules, NAT, and policy-based routing. There are three types of groups available. Port groups is for sets of TCP or UDP ports, including individual ports and port ranges, an IPv4 network, and IPv6 network groups. The network groups support traditional IP addresses and subnets, but they can also support exact host names and wildcard domains. That part's especially useful, but it's important to understand how these two domain-based match types behave because they're not the same. For exact host names, the system uses an Alta proprietary backend which resolves the host name, populates Route 10's DNS cache, which is also used by network clients pointing to Route 10 for their DNS, populates the firewall group, and keeps that group updated if the DNS answers change over time. The DNS record is refreshed and group updated as needed when the DNS TTL expires. This is the best choice when you want a policy to follow a specific, fully qualified hostname, which is kept current as IPs change. For wildcard domains, the backend uses firewall group integration in the Alta router's DNS resolver. In this case, matching IPs are learned only when a client queries a hostname that matches the wildcard. When that happens, the return addresses are added to the relevant group. Because of this, wildcard domain matches are demand-driven. They do not populate proactively, and they depend on clients using the router for DNS resolution. If no client has queried a matching hostname via the router, the corresponding IPs will not be present in the group. It's important to ensure clients are using Route 10 as their DNS server, or if you have internal DNS servers, that they use Route 10 for all their internet queries. So with that in mind, let's take a look at a few practical examples. For the first example, we're going to route an entire domain, star.example.com, out via WAN 2. So we'll go to Settings, Firewall, Policy Routing, and we're going to add a new rule here. We'll give it a name. Protocol any, source any. For destination, we'll click here to add a new firewall group. And we'll name it example-com to abide by the character restrictions of group names. And then the contents is the star.example.com. And now you'll note that group is selected for the destination. We don't want sticky connections. We want the target WAN 2. And save. Now, any example.com hostname that gets resolved through Route 10 will be populated in this destination firewall group and hence sent out via WAN 2. For the next example, we're going to configure a source-restricted port forward. We're going to open up a web server only for traffic sourced from a specific dynamic DNS hostname. This is vastly safer than opening a port to the entire internet since it keeps your attack surface limited to only the IPs the hostname resolves as. Ideally, a VPN is a better option to use, but for cases where that's not viable, a source-restricted port forward provides much better security than a wide open one. Note that in this case, you cannot use a wildcard domain. There's no assurance that any client will perform the necessary lookup, so you need exact host names which are populated by the backend automatically. So we'll add a new port forward here. We'll choose protocol TCP. For source, we're going to click plus to add a new firewall group. Give it a name. And we're going to allow ddns.example.com. Now the destination will be the WAN IP, or in the case of a dynamic IP, WAN any is fine. Destination port, we'll do 443 for forwarding. And then we're going to forward that to 10.11.1.10. The zone in is WAN, the zone out is LAN. So it's just the same as any other port forward, except we're specifying the source of the MyDNS group that we just added. For the next example, we're going to combine a port group and two network groups. And the intent here is to restrict IP phones. So we have a VoIP network with a cloud PBX, and we only want it to be able to get out on the standard SIP and RTP ports. So we're going to go to Filter, and we're going to add a new rule here. First, we're going to allow the traffic that we want. Protocol is UDP. Source, we're going to add a new group for the VoIP network. For the destination, we're going to add a new group to the PBX. And we'll specify that by hostname at pbx.example.com. And the destination port, we're going to add another new group here. Call it VoIP ports. And we'll use 5060 for SIP and 10,000 to 20,000 for RTP. Note that you do not want to set the source port the same as the destination port. If you do so, you will get a warning here because that is almost always the wrong thing to do. Source ports are random from the ephemeral port range and should almost always be any. So the zone in here will be LAN and the zone out will be WAN. And the action is allow. Now after we've allowed the required traffic there, we'll add another rule to block everything else from the VoIP network. We'll block all protocols. The source will be our VoIP network. Any destination, zone in is LAN, zone out is WAN, and we're going to use reject. That's generally friendlier for internal networks. And it will save. So now we're allowing the required traffic and then blocking everything else from that network. So that's the core idea behind Firewall Groups on Route 10. It'll let you define ports, subnets, host names, and wildcard domains once, and then reuse them across firewall rules, NAT, and policy-based routing. This makes your configuration easier to read, easier to update, and much less repetitive. The biggest takeaways are these. Use port groups for reusable service ports. Use IPv4 or IPv6 network groups for subnets, addresses, and domain-based entries. Use exact host names when you need proactive, reliable group population. Use wildcard domains when you want broader matching, but remember they depend on DNS queries flowing through Route 10. And always pay attention to rule order and the difference between source port and destination port. Thanks for watching.